Hey team, welcome back, and if you're new, welcome. My name is Ms. Danielson, and I'm looking forward to sharing a lesson with you today about indices, or powers, or exponents. Much like our friend Sonic the Hedgehog here is sharing power with his friends, and if there's 3 of them, surely each of them would get a fraction of that power, let's say 1/3 of that power. Today we're looking at fractional powers, whatever that means. I hope you joined us for our previous lesson on laws of indices and negative powers. If not, we'll talk about that a little bit today, but I'll link those lessons down in the description box for you below so that you can get yourself caught up before we get started. If you've already seen them, let's get into it. As I've just said, I'm hoping you're coming into this lesson with a good basic understanding of indices, but let's first just recap the different types of indices we might see. There are positive indices, for example, 3 as a power, simply means that we're going to multiply the base by itself repeatedly 3 times. So in this case, b times b times b. Or there are negative indices, which are the reciprocals of positive indices. That means that we're going to divide by the same index expression if that index were positive. So b to the power of -3 is the same thing as 1 divided by b to the positive 3. Again, if this is new to you, check out the negative powers lesson I've linked down for you below. Then, of course, there's the 0 index. Any base with a power of 0 will always have a value of 1. A lot of people get this confused and think the value is 0, so please don't make that mistake. So we've got positive indices, we've got negative indices, we've got 0 indices, and it seems like we've covered it all. But what about the indices that fall between positive numbers or fall between the negative numbers? Those are fractional indices. And fractional indices, like b to the power of 1/2 or b to the power of 1/3, are the roots. Fractional indices are roots, or the denominator of the fraction tells us which root it is. So for example, b to the power of 1/2 is the square root of b, and b to the power of 1/3 is the cubed root of b. Remember that when you square root, you don't need to put the little 2 here, although you could. When you cube root, you must make it clear that this is the 3rd root of b. So the denominator, whatever it is, tells us which root of the base we're finding. And we could have square roots, cube roots, 4th roots, 5th roots, 6th roots, any kind of root you like. Now let me try to explain to you why fractional indices are the roots, because of course the more you understand, the less you have to memorize. So for example, the square root of w, by definition, is the number that multiplies by itself, so multiply by the square root of w, to give you a value of w, right? Also, by the multiplication law, we know that w to the power of a multiplied by w to the power of b, since we have the same base, we add those indices. So if I use a fractional index, like a fraction of 1/2, w to the power of 1/2 multiplied by w to the power of 1/2, by the multiplication law, I would add the indices together, and 1/2 plus 1/2 makes 1. So that just goes to show that w to the power of 1/2 is the value that multiplies by itself to make w. So the square root of w, right? Take a minute to think about that if you need to, and then we'll go on. So the denominator of the index tells us which root it is. What about the numerator of the index? So for example, 9 to the power of 3/2. I know the 2 tells me that I'm going to find the square root of the base, but what does the 3 tell me? In order to work this out, you're going to need to remember your laws of indices. For example, we know already that the multiplication law allows us to add our indices together, so long as the bases are the same. You should also know the division law of indices. That tells us to subtract the indices, again, when the bases are the same. The power of a power law is the law that allows us to multiply the indices together. You should have seen these laws of indices in our previous lesson on laws of indices, again linked down in the description box. But let me demonstrate that for you here. The index 3/2 is the same thing as 3 times a half. So I'm going to use the power of a power law here. 9 to the power of a half to the power of 3 would be the same thing as 9 to the power of 3 times a half, which is 3/2. So first we'll work out the denominator root of the base, so the square root of 9, and then we'll raise that value to the power of the numerator of that fraction. So let me show you my working here. This is going to be equal to the square root of 9 to the power of 3. Now remember, when you square root a value, you have two possible answers. The square root of 9, if you do it on your calculator, will just say 3, but it could be positive 3 or it could be negative 3. Because positive 3 squared, positive 3 times positive 3 gives you 9. And negative 3 squared, negative 3 times negative 3 also gives you positive 9. So we need to give both answers, both positive 3 and negative 3. But don't forget we're also raising that to the power of 3. Positive 3 to the power of 3, which is positive 3 times positive 3, 9, times another positive 3 is positive 27. Negative 3 to the power of 3 is negative 3 times negative 3, which is positive 9, multiplied by another negative 3 will be negative 27. So again, we have two answers, either positive 27 or negative 27. Don't forget your positive or negative sign. It could cost you some marks. Very often, students confuse fractional indices with negative indices because negative indices bring about the reciprocal of the base. That's 1 divided by the base. So fractions. Let's not confuse fractional indices with fractional bases. So for example, 2 here, 1/5 to the power of 2. We can have a base that is a fraction, and if that fraction is in brackets and it has a power, that power affects both the numerator of the fraction and the denominator of the fraction. So that would be 1 squared over 5 squared, which is 1 over 25. For example, 3, the base is not a fraction, however, we have a negative index. And as I keep saying, negative indices give us the reciprocal of that same base if it had a positive index. So the reciprocal of that is 1 over 5 to the power of positive 2, and 5 to the power of positive 2 is 25, so that's 1 over 25 as well. Example 4, we've got a fractional base, 1 over 5, and we've got a negative index. Now this just shows us what a negative index does to a fraction. The reciprocal of a fraction is 1 divided by that fraction. And if you remember by cross multiplication how we divide by a fraction, we flip it upside down and multiply by it. So let's flip that fraction and put it to the power of positive 2. So that's 5 to the power of 2 over 1 to the power of 2, which of course is 25 over 1, which is 25. So let's not get that confused in our practice exercise. I hope we're ready for the practice now. Let me just first talk you through these questions. So for question 1, you need to evaluate the following. That means work out the value. Try to do this without a calculator so that you're sure that you understand what the indices are doing to the bases. In each of these cases, we got fractional indices. For question 2, evaluate these, leaving your answers in simplified fraction form. This time your bases are fractions, and your indices are fractions as well. For question 3, evaluate these, leaving your answers in simplified fraction form again. Now this time your bases are whole numbers, and your indices are not just fractions, but they are negative fractions. So you need to remember what fractional indices do to your base, as well as what negative indices do to your base. For question 4, evaluate these, leaving your answers in simplified fraction form where appropriate. Now this time, some of your answers will be fractions, while other answers will be whole numbers. So you need to decide what's best here. Looking at your indices this time, you've got some fractional indices, where the numerator of those fractions are not always 1. And you also have some negative fractional indices here. So remember what negative indices do to the base. For question 5, evaluate these, leaving your answers in simplified fraction form again. Here we have all fractional bases and all fractional indices. Watch out because you need to simplify your fractions whenever possible. If you think you're ready, go ahead and hit pause and give that a try, and hit play when you're ready to take up your answers. I hope you had a chance to hit pause, because here come your answers. For question 1, remember a fraction with a denominator of 2 means the square root. I hope you remembered your positive and negative signs in front of your answers. For A, it's plus or minus 8, B is plus or minus 10, C is plus or minus 1, and D is plus or minus the square root of 5. Now I left my answer as just the square root of 5. I didn't write the decimal answer because I know it's going to be a very long, non-recurring, irrational answer. So plus or minus the square root of 5 is actually what we call a surd. It's a way of expressing irrational numbers exactly by leaving them in root form. You may want to hit pause now if you forgot to put your plus or minus signs on your answer, so go ahead and fix that before we go on. For question 2A is plus or minus a half, B is plus or minus 4/5, C is plus or minus 1 2/7. Did you notice that your answer was top heavy and you had to simplify that fraction, so making it a mixed number? See if you need to do that anywhere else before we go on. Question 3A is plus or minus a third, B is plus or minus 1/5, and C is plus or minus 1/12. Question 4, I hope you remembered to do the root and then raise that answer to the power of the numerator of these fractions. Question 4A is plus or minus 64, B is plus or minus 32, C is plus or minus 1/27 because we had a negative index there, D is plus or minus 1/216, and for question 5A is 9/25. Note this is not positive or negative because I didn't do the square root, I did the cube root. We only put the plus or minus if we've done a even numbered root of the base. So B is not going to be a plus or minus answer either. It's just positive 1/4. C, however, was the fourth root of 81/16 to the power of 3. An even numbered root will have a positive or negative answer. So this is plus or minus 3 3/8. I hope you remember to convert your top-heavy fraction into a simplified mixed number. So how did that go for you? Hopefully it went fairly well. If you had any difficulties or concerns, please let me know down in the comment section. Otherwise, well done, keep practicing, and I'll see you soon.